In today's topic, actually, I would like to go through file systems basics, and I would like to go over the disk partitioning, the mount and unmount things. I think that's all. That's that much only I can cover, I believe. So we'll go over that now. So agenda is, as I had mentioned, so it's going to be file system basics or introduction of the file system, and then we will go through the partitions. What are the partitions, types, and things like that, and also the file system types. Also, we'll be looking at. Actually, logical volume management. I don't think I can do it today, so we'll do it tomorrow. Yeah, so these are the things that I'm having in mind for today. Okay, so coming to file systems, what is the file system is all about? So file system is something which is basically is a method for organizing and managing files. When we say organizing and managing files, so this means including storing the file, accessing the file, that is read file, write content to a file, or it could be retrieving data from the disk, things like that. So for all of this, actually, there's a concept, there's a method that we need to have so that the system would be able to easily retrieve the data that we have stored. So to explain a little more, so I have a small diagram here, picture here. So I thought it is actually giving a good idea. So in real terminology, real day-to-day things, we have different shells to accommodate different files and folders. So similar way, and we keep a name over it so that we can easily retrieve it. So this is what we do it in our day-to-day life. So the same thing is what is being done in the file system, in the computer systems as well. And this is a critical piece in the operating systems. So there are various types in the file system. One is ext4, ext3, ext, xfs, ntfs, FAT32, and things like that. So we'll quickly go over all of these in a moment. Files are arranged, Safi and Senthil, in case if I'm going very basic, you can ask me to skip so that I can skip and then move on to some other topics, or I can skip some slides. However, I am going in this phase, but you can let me know if I need to correct.
Okay, that's okay.
Yeah. So Linux actually deals with only two items that we have to keep it in mind. So this, unlike other operating systems, it has only, it deals with process and files. These are the two entities Linux would deal with. All the things, I mean, including hardware and everything, are visualized as as in the form of files. And other than that, we have the actual software, which is called the processes that are running in the Linux operating system. Only two entities are there, files and process. This one thing that you need to keep it in mind. And the files system here is arranged in a hierarchical directory structure, starting from the root directory, and under which we have the subdirectories and files. So these are a few things, and yeah.
There is some disturbance in your audio while you are speaking. For a minute, it's coming okay, then there is a disturbance.
So is it a break, or is it some background noise? How about now?
Yeah, it's like stretching your voice while you're speaking. Okay, a few words we can hear clearly. Then your voice is like, stretching. Oh, like this.
Oh, I see. Okay, in my internet.
I don't know. It's because of your mic or connection. We don't know.
I think maybe could be because of internet. I'm expecting it should get sorted out now. Let me know if you still face the issue.
Okay.
Yeah. Yeah, so Linux file system has the following characteristics, which means it is the one that does the file organization, and it's the one which takes care of file naming convention. So depending on the file system, the naming convention, the length of the name, and things like that are defined by the type of file system. And file metadata is one thing that is the one that gives the information about the file owner and when it was created and where it is located. All of that is the logical data structure, just hidden within the file system. And it's also gives the responsible for giving the access control. And we have the file compression, file fragmentation, file recovery, and we have the file system performance, file system scalability. All of these things are the jobs that are done by the file system as a background. So just given that list. Okay. Now, when you see the file system, so you have at a high level, we have two kinds of file systems. One is disk file system. The other one is the network file system. So the way it is segregated is based on the file system which is available over the network. So when we say network file system, so some storage that we see in a system may not be actually present within itself. Instead, the storage would be present in some other remote location that we are sharing it within by the client or the nodes for its usage. So it'll appear as if its own partition, but the actual storage would be in the remote end. So this is the network file system. So we have two kinds of network file system that we have. One is NFS, which is called network file system, and the other one is SMB. SMB is Samba. So the difference or the details, we will have a separate sessions to get into NFS and SMB. We will do that. NFS is a concept which was developed by Sun Microsystems, and SMB is a concept which was developed by Microsoft. So NFS, when you say NFS, will be able to take care of only within the Linux-based systems, and SMB can take care of sharing the partitions across all operating systems. So this is the one thing, but we'll get into more of these details in the specific class when we get into. Okay, coming to the disk file system. So this is basically is a file system which we have it within the physical disk that we have within the system, and there are so many varieties of file systems that are there. I just listed only few things. EXT, it started with Minix is the first file system that that was developed, and then EXT1, EXT2, EXT3, EXT4, and XFS. These are the XFS is predominantly being used in Red Hat, and EXT4 is predominantly being used in the Ubuntu-based systems. And if you see NTFS is a Windows-based file system. And if you go to cloud, you have EFS, Elastic File System, and so on. So many other file systems are there. So all of these file systems, as I had mentioned, so these are file systems which will work upon the physical hard disk that we have within the local system. Okay. Okay, so the types, file system types. So we have the ext for all of that we have seen. So one word about all of these is what I'm going to say. Just browse through. So ext stands for extended file system. It's a 16-bit internal addressing, and it can hold a maximum size of 16 TB. So that's the size it can hold. But later it was we have the ext4, which was very similar to ext3, but has got an extended storage limit, which is of maximum 1 EB. The ext3, ext4 all were having the features of journaling. So journaling is something which will be very useful when something goes wrong in between. and if you have to roll back the job that was being done, so that it is gracefully brought back to the original state. So this was not there in the earlier file systems. Now ext3, ext4 were having that. JFS is something which was developed by IBM system. So NTFS is the one that is being used by Microsoft. And we have the XFS is the one which is high performance file system that performs parallel IO operation, fast data recovery, and in case of crash. So this is the one which is available in Red Hat systems, meaning CentOS is having XFS by default in its partition. So we'll take a look at that. So EFS, I told, this is one that's being used in AWS EC2. Okay. So in case if you want to know which file system is running in your system, you can give this command parted -L or -T. So all of this will tell us the file systems that is running in our system. Okay, maybe I can show my system also. So I have the partitions. I have 3 disks in my system at the moment. There's a SDA, B, and C. So the SDA, B, and C are called as the disks or the physical disks. So in real time scenario, so these are actually, if you have a on-premises equipment, this actually we have hard disks in different sizes. So we'll have to buy this hard disk and have this installed in our hardware. And once we install this, these kind of names will come. So the more number of disks we have, so it will go on with SDA, B, C, D, and so on. So with this disk, we can have our partitions. So in my case, SDA, I have 2 partitions, SDA1 and SDA2. So these partitions are created by the CentOS itself during installation. So these are, I am not done on my own. These are done by the system. And SDB and SDC are created by myself, and these are 1 GB each. Okay, so if you want to see which file system is there, so you can see these file systems are shown over here. So if you see, the root is mounted on this LVM. This is done by CentOS, and the file system is XEFS. So this is a file system that's used by CentOS, and the ones that I have created are also created based on XFS. And okay, so there's a concept called mounting. We'll get into mounting in a moment. Okay. So coming to the file system structure, so it's a 2-part file system software implementation, but though it's a theory, I think like it might be good to know this information. So there will be an API which will be called from the user applications, and this kernel would have this API, and which will invoke the commands that are given by the virtual file system. And this virtual file system is a layer which will be having the respective drivers for the actual file system. So suppose if we have ext4, and we have to have the ext4 driver software, and this driver software would be called or would be invoked by this virtual file system but the virtual file system will have a common set of commands. So based on the file system that we have configured, these commands will invoke the respective file system drivers to do the job. So what are the jobs of file system operations? So it's a create operation, file create, file delete, and sometimes we may need to copy also. So all such operations are done by this way. So this is what is called as the two-part file system software implementation. And it's possible to have multiple file system within the same system. Within a same local system, we can have multiple file system running on it. There is CMPFS, but if we have Ubuntu, so the boot is stored in Path32. Path32 is a plain DOS based DOS based file system. So, but in CentOS, it's all XFS. Everything is XFS. But so what I'm trying to say is all of these. It is possible to have multiple file system in the same system, and we may have to configure that in the partition which kind of file system that we want to have in that partition. Okay, so this is the directory tree structure. You might have noticed these directory tree structure. I'm going to give a quick overview of what is this, what is the functionality of this things. When you see the systems, if you go to the root directory, you will have this. You will see this. Root directory, and root directory, you have the directories like bin, etc, sbin, usr, var, dev, home, lib, lib, mnt, opt, proc, root. So these are the directories that you would see in case if you go to the root directory and put ls, list the directories and files under the root directory, you will see these kind of directories here. Okay, so what is the purpose of these directories? So bin is a directory that's a short form for binary, which means all user command binaries are stored here. So binaries in case if you're wondering what's a binary is something is a piece of software which would be used by the system to understand. So it will be in its own language is the binary language. So the system can able to execute it, and then it can able to understand it. So all of the commands like chmod, cat, cp, date, all of these commands that we give in the shell terminal will invoke this binary program, and which will do the job for us. So all of the user command binaries are stored under the bin directory. Okay, coming to next one, which is the etc directory. So if etc directory is something which we have all the configuration related files for the system. So if you see Linux basically will work like this. So each and every application would have a equivalent configuration file which is stored in the path under etc. So you don't, if you want to change the behavior of an application or a service, you may need to change the configuration file which is present in the etc directory, and you may have to restart it. This is a common concept across all the application and services. So the configuration files are stored under this, and you have different configuration file for different purposes. And in case if you have your own application, you might have to have your own configuration file also in this location. So this is a place that we have all the configuration files. So whenever we start an application or when we launch an application, the equivalent configuration file would be looked up by the application, and based on the parameters that are there in the application, on the configuration file, the application would be launched. So that's about the etc directory. Coming to the sbin, so this is also having the binary, but these are system level binaries. So all of these binaries are only applicable for the root or the system level users. So most of the things like fsck, yeah, so most of the things which are used by the system level things are binaries are stored over here. So next comes the USR. USR is the Unix system resource directory. So this has the subdirectories like user bin, user include, USR lib, and USR local, USR share, all of that. So you have some more commands that are there in some command binaries are there in here. And include will have the include which is required for the development, C program development, or whichever programming that we do. So there's a piece of thing that we would include, and those things are all present here and the libraries. So these are actually meant for C programming, Java programming, and things like that. So all of these things are stored over here. And local is the place that we have our local software. So whatever software that we install or whatever thing that we install on our system, so it will get presented in the USR local. So and USR share will have the static data shareable across all architectures. So that is the data that would get shared across all architectures. So yeah, there are multiple architectures. We have x86, and things like this. Some data are common for all of these architectures. Those things are stored over here. And finally, you have the USR share man. Man is nothing but the man page. I think you are aware of this. Man is a manual, the built-in manual which is stored in the Linux system. And even before the internet days, they have architected in such a way like we don't need to run for documentation separately. We can directly put the man and the command after that. It will give the documentation and the manual page of the particular specific man. So that's a manual page. So these are things that are stored in the USR. And if you go to VAR is actually meant for variable data files. So which means the file sizes can increase. So based on the usage and things like that. So it would include cache directory, and some lib directory. Log is one thing which we might use as a system administrator. We might have to, if something is not working, the first place that we need to take a look is the log file. So the log files are stored over here, and the log files are something which will grow. So as the system is switched on for a long time, so log files would get refurbished once the file size reach the maximum limit. So it will store again. Where spool will have the related things about the mail, email, and under spool we have cron related things, cups, and mail related things. So, and where temp will have the TMP will have the temporary files saved in reboot. So all of the files that are saved between reboot are stored over here. These are the things that are there under where. And if you go to dev is a place where you can find all the device related files. So all the hardware files are stored over here. We have the hard disk file, keyboard, monitor, all the device files, all the hardware device files. You can not only hardware, there are software devices are also there, which are developed for the system operation. So all things can be seen in the device dev directory. If you put ls/dev, we can get to see all the device related files. And next is the home directory. Home directory, we know this is the home directory which is available for the user accounts that we have. And this is the place that any logged in user will have full access to. So all other directories are limited to the root user or system admin user. Only the home directory is the place that the user is given access to. So lib is a place where we have the libraries that are required to run for the system. Mount is a default placeholder for using as a mount point. So mounting is a concept where we have to actually mount the given storage onto a location in the file system so that the Linux would be able to view it and access it and do any operation. So mounting is that concept. We'll do that in a moment. So by default, the placeholder is given for /mnt, under which we can create any directories and use it for mounting. So OPT is meant for optional software, and then we have proc. Proc is meant for proc file systems, which is used to change the configuration of the kernel when the kernel is up and running. So instead of changing, generally kernel configuration needs to be changed when the system is off or switched off. So by changing the MK config and things like that. But in case if you want to change the functionality of the kernel, you can use the proc file system, sysctl, and things like that to dynamically change the operations of the kernel when the system is running. So we can change the parameters on the fly, and parameters that we have changed will get applied immediately by the kernel, and it will be visibly shown. So visibly seen. So this is a feature that's architected in the Linux, which is a good one. And apart from that, we can proc is a control and information center, which means like all processes that are running the system can be. This will give us a dashboard kind of thing, like what is the present status of the particular process, whether it is dying or running, or whether it is idle, things like that, and how much memory or related to each and every process can be seen in this proc directory. And the root is a directory which is used by the root user. Like any other user, root has its own root home directory, and this is under the location /root. So this is our root directory structure. And we all know that when we access a file, so Linux would like to refer it based on the root. So if we simply give a specific file at a special location, he'll not be able to understand. He will have to expect the complete absolute path. If you want to give a relative path, we may have to give it from the there's nothing like relative path. So Linux can understand only the absolute path starting from the root directory. So that's about the root directory structure. So we'll move on to this one. Okay. Okay, now we are going to see about partitions. Okay, disk partitions. So uh, to give a quick analogy, so if we have a big space, living space or anything, so we normally use it by partitioning it. Why do we do that? So for efficient usage. So if we have a big space, living space, so we segregate into living room, dining room, and things like that. So that's for efficient space, and this is the very reason that we have partition in the systems as well. Partitions are logical units created on a drive of a specific size, and it's for efficient usage. Information about the partitions are stored in a partition table. This partition table is present in the first sector of the disk, and it is called MBR. MBR is the first sector of the disk, and where we can see the partition table information. So we'll see what is the partition table information. So if we see here, this where the partition table information is stored. So once we partition the disk, so we will have to enable the file system on top of it, which file system we would like to use for that partition. And that's called formatting. And only when we format the disk would be, or the partition would be ready for use. So we'll have to partition, format, and mount. So the three processes are to be done for the before using the disk. Okay, so the picture that is there at the bottom is showing the original disk space is here, and we have the first boot sector, we have the partition table information, and in this case we have three partitions, partition 1, 2, and 3, and each and every partition we have a logical structure information of the file system along with the data. So data is one that we know. The logical structure is the one that I talked about as metadata. So all of these metadata, which has the inode, super block. So all of these things are stored here, and for each and every partition, so this logical structure would be there, and along with that there will be a data that is storing inside the partition. Okay, so Coming to partition types, there are three kinds of partitions. One is primary partition, second is extended partition, logical partition. Primary partition is generally where the operating system is booted from, and we may need to set as active to notify that the OS that this is the place the OS needs to be booted from. And coming to extended partition is special primary partition, which can be subdivided into logical partition. This is a special primary partition subdivided into logical partition. You can see the things that is shown in this picture. So the physical drive is shown in the green cylinder, so at the outer side. Under that, we have a primary partition, which is shown in blue disk, and we have the extended partition stored in yellow disk, yellow cylinder kind of thing. And under that, we have the logical partitions, which we can create inside the extended partition. Extended partition can have any number of logical partitions. These are the different kinds of partitions that can be there in the Linux system. Okay, so when we have a disk which needs to be included into the system, so as I had mentioned, we need to insert the disk that we have purchased from the market, install the disk that we purchased from the market in the hardware that we have. Once we insert or complete the hardware installation, the next thing that we have to do is the partition. So this partition is the one that we just now seen. So basically, we'll have to create the partition, and next one is the while doing the partition, we'll have to mount it. We may have to mount the partition after formatting it and the mounting it. Once we mount is complete, so the partition will be there as part of the file system. So that's how it will be, and we can see the things that this is the below. I mean, these are the steps that we can do to have to create a partition. Okay, so I'm just given this steps based on the virtual system. So I have the virtual system, virtual machine. In case if you have a actual system, it might be a little different, but so these steps are meant for the virtual system. So first thing is we need to go to the VirtualBox manager. This is the hypervisor. Go to the hypervisor and add the artist that you want to add. And that's very similar to the one that I just talked about, like after purchasing the disk from the market, so we'll have to insert it in the or do the installation in the do the hardware installation, and once we finish the hardware installation, it will be available for use within the system, but it will not be seen by the Linux, or Linux will not be able to access it since it is not mounted. So that's the first step. And second step is actually to second step, we can view the added disk. And third step is where we want to create the partition. And the command to create the partition is fdisk and give the name of the disk. So if the name of the newly added disk is DevSDB, so we can give the disk name here. And fdisk is a utility, and it will ask for multiple options. And we may need to first to create a new partition. P for primary partition, and we can give the first sector and last sector in case if you are aware. Otherwise, we can keep it as default. And we can press T for formatting or keeping it in the Linux. Since we are going to use it for the Linux operating system, we have to give it T. And once we finish it, so we can say the partition by giving W. So this will get updated into the partition table. And after fourth step, we can create the file system. The command to create the file system is mkfs.exfs/dev/sdb1. So previously it was sdb. Now we have successfully created the partition, and we will have the partition name, which is 1, 2, 3. Partition names will go by 1, 2, 3, 4, and so on. So we can see the partition name that we have created. So partition name would be sdb1, and we can give the sdb1 here, and that will create the file system. And once we have the file system, so the command last command is to mount the file system onto the location, onto the root directory structure, so that the newly added disk storage would be visible for the Linux system. Okay, so I'll quickly show this in the Linux. So this is my virtual box. Not sure whether how far is relevant to you, but however, I thought I'll show it to you. In case if you want to add a new disk, so you'll have to click this SATA, and then so first we have to switch off the machine because hard disk session is not plug and play. I mean, it cannot be done while the system is on. We'll have to switch off the systems. I have another system to switch off. So if you see here, so go to storage and SATA, and you can add hard disk. And you may have to create one. If you don't have, I don't have anything, so I have to create one. I create one, so it'll by default say the VirtualBox disk images. That's what it is. And I don't want to pre-allocate, so you can give the size 20 GB. I'm not going to click the finish button because I don't have that much of space. So once you click yes, so you'll have the disk created. So once you have the disk created, when you switch on the system, you will be able to see the disk visibly seen here. So in this case, I have two disks. This is the main disk, which is of 35 GB, and I showed you SDB and C. So SDB is 1 GB and C is 1 GB. So these two disks that I have. And in case if I want to uninstall hardware uninstallation, I have to switch it off, and then you have to remove it. I will show that. So yeah, I can remove one of this. If you see here, so remove is enabled here. If I remove it, it'll not be. It'll be just showing one disk. So previously, I had two disks, so it'll be showing only one disk now.
Alex, you are speaking. We cannot hear you. Yeah.
Yeah. I'm not speaking, Sapisa. I'm just
Okay.
waiting for
Okay.
my CentOS to come
Okay.
up. I'm
No problem. No problem.
yeah. I just now removed the one of the disk, and now once it comes up, I will mount. I will create a partition. I'll remove the partition in the disk, and then I'll recreate it, and then I'll format the file system, and then I'll try to mount it. So once we do that, you'll get to know what is happening. Meanwhile, we can see the additional commands. The commands, I think BLK ID is a command that we can use to know the file system for a particular partition, which file system is running. So we can use this command. And to create a file system, we have this command mkfs.xfs. XFS is a file system if I want to create. If I want to create ext4, we can give mkfs ext4 and give the partition name. So /dev/partition. And default mount point is there as /mnt. We can create any directory and use that mount point for any of the partition that is there. And mounting can be done based on three ways. One is using the partition names, and you can also mount using UID, which is what is more preferred. UID is unique ID for a particular partition, and this is will change. So what I'm this partition names might change. So as you move on, suppose if you add disk, unmount it, and remount it. So previously it was SDZ, and now it will become SDB. So such kind of confusion might come. So but UID will be very unique, and we can have the mount command based on UID, and can also be done based on the label name as well. And mount and unmount we know. So mount is mount command mn. So basically mount is this is the command mount, and give the partition, and the next parameter is the destination mount point, and umount is the command to reverse it. So once you give umount, the storage location would not get mounted. It will be it will not be visible as part of the Linux tree. Auto mount the partition. So auto mount is something basically when you want to have this partition mounted whenever the system comes up. So we don't want the mounting to be done manually once the system comes up every time manually. Instead, we want to have this created, or the mounting done by default. That's called auto mounting. For doing this auto mounting, we have to give a configuration, the etc fstep file. This is a configuration file, and we'll have to give the format. There are actually 6 fields are there. So first thing is the file system. You may need to tell which file system. So either you can give the name of the file system, or you can give the UUID, as I had mentioned. And then the mount point, which mount point. So this is a sample that I have. So you see here, this is a sample. MNT, new disk, and ext4 is the file system type. If you want to have XFS, we can have XFS. Defaults and 0, 0. Now the new disk should be mounted automatically at boot up. Following command would be used in case if it's not done. So in case if you see that it's not happening, you can give the mount -EA for the thing to have this mount done just after booting, or just after creating this fstar file. So the mount -EA command will execute the configuration that we are given in the fstar file. Okay, so the fields that are there are given here. File system we know, mount point we know, type we know, options, mount parameters to be considered when mounting the file systems is the option. So we say that default options is fine. And the last is zeros are meant for dump and pass. So dump is basically means this for the backup purposes used by the dump utility. 0 disable the backup enabling thing, but I have not verified whether how far it will work. And the last number is actually 0. So pass, this means file system check and boot time. So this will do a quick check of the file system using the fsck utility, and 0 disables this. So I have made it 0, 0. In case if you want to have this, we may have to give the number here 1 and 1. Okay, so that's about it. So let's see if this system has come up.